Good evening, Year 10s. This video wasn't originally going to be made, but some of you asked me to on our Collaborate session. So I'm just going to go through this very briefly, mostly focusing on the real balancing of equations. So for this is mostly about a recall from looking at some of the stuff you should have remembered from Year 8 and Year 9. Remember, I do always tell you that everything in science builds off what comes before, so you do kind of need to remember some of those earlier things. And we're going to look at a couple of things, what is a chemical reaction, structure of an atom, common vocab, and a balanced equation. And I think this last skill is the one that is giving most of you some difficulty. So, looking through here, knowledge shouldn't be too terrible. However, the skills, how do I balance an equation, is the thing that most of you want help with. Now, for this video, if you do happen to hear any screaming, that's my wife watching It with our daughter. So, yeah, it's not the chemistry that's scary, it's the clowns. So, first bit was some vocab stuff, and these words here we provided for you to look up as definitions. And there is a text here for you to have a read through. Don't forget, on the eLearn site there is also a very good textbook where I have identified step by step or chapter by chapter what topic it relates to, so definitely have a look through that. Okay, so let's get to the crux of it, and I provided you with this table of, 14 different equations to balance, and we're going to use the same process. It doesn't matter if we're doing what looks to be a simple one, like one of these, or one of these harder ones. It always will use the same process, and it will generally work all the time. Okay, let's get started with it. So, here's the first one, and I'm just going to work through the same way. I'm going to show you a couple of ways to do each one. The first is the ERP table, and the second is sort of just using your idea of lowest common denominators and lowest common multiples to work things out a bit quicker sometimes. So first, we can do this the longer way. Always start with writing ERP, and we want to first off identify what are our elements here. We can see we've got a hydrogen and we've got a chlorine. Now this side of the equation, that's my reactant side, and this side over here is my product side. So on my reactant side, I can see I've got H2, so I have 2 hydrogens, and I have Cl2, I have 2 chlorines. But on my product, I have just one of each. Now because my product side has less, I'm going to have to work with my product side first. Now you can do a little bit of quick math in your head and go, well, I've got 1 hydrogen. Okay, let's ignore the chlorine for a second. I've got 1 hydrogen, I need to get to 2 hydrogens. What do I multiply 1 by to get to 2? And 1 times 2 is equal to 2. But if you're not certain of what you've got to add, just draw one at a time. So this one's going to be pretty easy. I just need to go, well, let's go HCl, and now let's recount. I've got 2 H's, so that's now a 2. I've got 2 chlorines, so that's now a 2. So, and now I can see that I'm balanced. So my net result is, well, I've got H2 plus Cl2 gives 2 HCl. So as long as you always start with the first, as long as you always start with just one element that's in one place, that is less, you'll generally find this to be an easy process. Feel free to just draw them on one at a time if you need to and recount each step. You don't have to jump straight to the end result if you can't see it, but if you get paralysed and going, oh, I don't know how to get to the end, so I'm not going to do anything, you generally won't find it too easy to get through. Alright, let's go on to the next one. Okay, this one again from our table. This one's a little bit more complicated. We can see we've got a Ti, titanium, a chlorine, a hydrogen, oxygen. So we've got 4 elements now, but I'm going to start the same process. There's nothing to, while I did say there'd be 2 different ways, the first one isn't really something we can do a couple of different ways, so I will not worry on that one. skipping a little bit. So T I Cl H and O. Alright, so going through here, I can see we've got one titanium on each side. I've got 4 chlorines and 1 chlorine. I've got 2 hydrogens, 1 hydrogen. I've got 1 oxygen, 2 oxygens. Now, in all cases here, every element's only in one place on both sides, so it doesn't matter which I start with. We can just go with whatever. This one's going to be a good example for showing the 2 different methods, because we can do either method, and it's not too long, but we know that there is a faster way to do it as well. So let's start with the chlorine. I've got 4 on this side, and I've got just in one place and only 1 atom of it here, so I know I'm going to have to go, well, HCl, now that gives me 2 chlorines, HCl, and now I've got 3, HCl, oh, great, now I've got 4, so that's done. Let's recount. I have 4 chlorines now, but I've got 1, 2, 3, 4 hydrogens as well. Okay, now titanium's okay, so I don't need to play with the titanium. Let's go with the hydrogens, because the hydrogens now have more on our reactant side, so on our product side than on our reactant side, and the oxygen also has more on the product than the reactant. So if we mess around with our hydrogen here, we can see it's also attached to the oxygen. That might fix our problem. So what do we need? We've got H2Os, and we've only got 2, we need to get 4, so we're going to need another multiple of 2. And if we recount now, we've got 4 hydrogens, so that's good, and we've got 2 oxygens. Okay, we're finished. Oops, that was 0, 2. And we can see we're finished here, so our balanced equation would be TiCl4 plus H2O gives TiO2 plus HCl. Oops. 2H2O plus. Actually got to write the balanced equation at the end. And that's our end result. Now, you may kind of have clued in a little bit there as doing it, so I'm going to do now with the faster way. So I'll rewrite the whole equation. TiCl4 plus H2O, and actually what I'm going to do is I'm going to write it with a little bit more space in front of it. TiO2 plus HCl. Okay, so now what I'm going to do is jump to the end process. I have 4, I have 1. I know that I can have, I need to have these being equal, so 1 times what equals 4, so I'll write that down, 1 times what, actually that looks like a 0. 1 times what equals 4, well, 4 obviously, and so that tells me I have to slap a 4 here. And now I can go, well, I've got 4 HCl, for the 4 H's, I've got 2 H's here, so 2 times what equals 4. 2 times what equals 4. Well, 2 times 2 will equal 4, so it tells me there has to be a 2 there. And then if I keep checking, I can see TI's balanced, the O's are balanced, the CL's are balanced, and so all these things work out. We could have also gone, well, 1, because there's 1 oxygen, times what equals 2, because we've got the 2 oxygens there, and well, that's also 2, so that's good, that all balances out. If you're going to do something with multiplication, you just need to ask, well, what do I need to slap right in front of it? Sometimes people have issues seeing that though, and that's why I like to teach this method, because even if you can see the end, you can always fall back on this pretty easily. Okay, now this one is not on the 14 that I've given you. This is a new one, and I don't know the balance for it. I just tried to look up one and grabbed a random formula. And looking at this, we can see I've got Fe2O3, so that's rust, plus carbon, produces Fe plus CO2. That's how we get rid of take ferrous oxide and we reduce it down to pure iron by burning it off. Okay, well the C's balance. I'm going to do it the other way. I'm going to do it the multiplication way first, and then I'm going to do the ERP table with the adding of values. So C's balance. Iron. Oh, the iron only needs one extra added because we've got Fe2 on one side and Fe on the other side. That's pretty good, so that just balances. But the oxygens don't balance. We've got an O3 and an O2. That's actually where I'm going to start. And the reason I'm going to start with that is that they are different common multiples. There's nothing there's no whole number. I shouldn't say there's nothing because obviously 2 times 1.5 would give us 3. But there's no whole number I can multiply 2 by to get 3. So I'm going to have to scale both of these up, and all I'm going to do is cross multiply them. I'm going to multiply the CO2 by 3, and that's simply because, I'll highlight it, it's simply because of that 3 there. I'm going to multiply the Fe2O3 by 2, simply because of that 2 there. And so that will give me 2 Fe2O3 plus C gives me Fe3 plus 3 CO2. And now the carbon's not balanced, and the iron's even further away from balance, but the oxygen is balanced. If I'd started with the iron, I could have started with the iron. What I would have discovered is I would have had to go back to the iron to rebalance it. Okay, so now let's have a look. I've got 4 ions on this side, 1 iron on this side. So I'm just going to need to slap a 4 here, so now I've got 4 and 4. I've got 3 carbons here, 1 carbon there, so if I slap a 3 there, we should be done. So let's recount. I have 2 Fe2s, so that's 4, good. 2 O3s, that's 6, 3 O2s, that's 6, good. 3 Cs, done, excellent. If we did it with an ERP table instead, Fe, C and O, the original formula was 2, 1, 1, 1, 3, 2. So if I do it with the original, I'm going to rewrite it here. Fe2O3 plus C gives us Fe plus CO2. Okay, well I don't have enough Fe, so let's add another Fe over here. So that makes it 2. That's good. Iron's done, carbon's done, oxygen. Don't have enough oxygen. Let's add a whole new molecule, because remember you can't just add we can't just add one of the atoms. We can just slap an O on there. We have to add the whole thing. We have to add the whole CO2 molecule again. Oh, okay, well that's stuffed up a couple of our balances, because that's now at 2 and that's now at 4. Okay, let's get back over here, because now we don't have enough oxygen. We don't have enough carbon either. Let's add another carbon. Cool. Now we've got 2 carbons. That's balanced again. We still don't have enough oxygen, so we're going to have to add a whole nother Fe2O3. Fe2O3. Okay, so now we've got 6 oxygens. That's not balanced. We didn't mess up the carbon, that's okay, but now we can see we've got 4 ions. Phew, okay, so let's go back to the other side. Well, 4 ions, that's an easy fix. Fe, Fe, cool. Now we've got 4 ions, but we don't have enough oxygen. CO2, 1, 2, 3, 4, 5, 6. That's 6. Okay, we're up to 6 oxygens, so oxygens are done. We have 1, 2, we've now got 3 carbons. Ugh. 3, sorry, not a C. But that's an easy fix. We just throw a C there. And now we can see we've got the same thing as before. 2 Fe2O3s plus 3 C's plus 4 Fe's gives me 3 CO2s. So even though like that way can be messy, it can be longer, it will work, but you have to do the process. Okay, so through this big idea, and especially this yellow one here, is you can determine a balanced equation, and you will need to do a little bit of that. You could expect something like that on an exam, at least a question like that on an exam. It's not a knowledge style exam, it's a data skills exam. So if we do ask you to balance an equation, it would be an equation in relation to a particular experiment. But for your assignment, being able to balance an equation may certainly be a useful skill to have for you to give a good complete demonstration of your knowledge. Alright, so hopefully that helps bring back a few memories, and hopefully you can complete the other 12 questions I didn't do. One of those 12 I did do on the Collaborate as well, so if you went and watched the Collaborate, then you've only got 11 that you need to figure out for yourselves. Take care guys, see you soon.